We're continuing to solve systems of linear equations by graphing. So let's look at another one. Let's say we have the system of equations y equals x over 2 minus 1 and y equals minus 2x. Okay, so here is our system of linear equations. We have call this equation 1 and line 2. All right, so let's go ahead and pick out a few points. We're using the old pick a value and plug it in to find a point strategy. So we'll do it with a couple more examples, and then we'll move on to another strategy. So for line 1, we have the line described by the equation x over 2, y equals x over 2 minus 1. So let's go ahead and pick out a few points that'll make getting these a few values for x. So it'll make getting the points very simple. One is an obvious one, x equals 0. So when x equals 0, y equals 0 over 2 minus 1. This is just 0, so y equals minus 1, which gives us our first point on the line, 0 minus 1. Let's pick out another simple one. Let's use x equals 2. X equals 2 instead of 1 will actually keep us from having to deal with a fraction because we have a denominator of 2 here. All right, so y equals 2 over 2 minus 1. 2 over 2 is 1. 1 minus 1 is just 0. So we have the point 2, 0 on our given line. And let's just go ahead and use minus 2. Again, we want to incorporate negative and positive values for x to get a taste of what's going on both sides of the y-axis. So we have y equals minus 2 divided by 2, just plugging it into our equation, minus 1 equals, so we have minus 2 over 2 is just a minus 1, minus 1 and minus 1 is minus 2. All right, so our third point on this line is minus 2, minus 2. And that is, that's 3 points that lie on line 1. So let's go ahead and find some points that go for line 2. Then we can go ahead and graph both of them at the same time. Line 2 is described by the equation y equals minus 2x. So let's just go ahead and plug in a few values for x. So when x equals 0, y equals minus 2 times x, which is 0, which just gives us 0. So we know that line 2 will pass through the origin, which is 0, 0. Let's pick out just a couple more simple ones. X equals 1, y equals minus 2 times 1, or just minus 2. This gives us our second point, 1 and minus 2. And let's go ahead and get a negative value for x. Let's say minus 1. So y equals negative 2 times a negative 1, which the negatives will cancel, giving us a positive 2. So our third point is minus 1 and 2. So we have 3 points for both of our lines. So let's go ahead and plot them and see what this graph looks like. There's our y-axis, there's our x-axis. This is the positive direction for y. This is the positive direction for x. Our values are quite small, so we don't need to scale this too much. Okay, so let's start with line 1. Line 1 goes to the point 0 minus 1. It also goes to the point 2, 0, and the point minus 2, minus 2. We can connect these with straight as line as possible. And there is the graph of the line y equals x over 2 minus 1. Let's go ahead and label it. We always want to label it just so we know which line we're working with, and that'll actually get important in a later section. But let's get in the habit of doing it right now. We know the second line goes to the origin, which is right here. It also goes through 1 and minus 2, and minus 1 and 2. Let's go ahead and connect these 3 points. And sometimes we'll use a little imagination that it's going through these 3 points, just because I can't draw very well. All right. And this is the line described by the equation y equals minus 2x. All right, so what are we looking at here? Well, this is the graph of these two lines on the system of equations. Once again, it's just not giving us It's only an approximation of the solution for these system of equations when we're graphing them. The exact solution for the system of equations happens to be 1/5 and minus 2/5, which if you look on the graph, it actually is pretty accurate. This is the solution, this is the intersection point, and this is actually the values for the intersection point. So while this is just a visual representation, this is the exact solution for this system of equations, and we'll show how we get this in some future sections. So right now we're just getting the habit of graphing both of these, labeling them as what they're called, and seeing how they relate to each other. That's the most important part here. We just want to get in the habit of being good at graphing, I guess. So it makes life much easier. So let's look. Let's go ahead and look at another one. We have the system of equations x plus 4 is equal to 4y, and minus y is equal to 3x plus 2. Okay, so looking at these two equations, one is in point-slope form, and the other is in, well, close to slope-intercept form. We just have a minus y out front, which we can deal with very simply in a second. So let's just convert both to slope-intercept form and pick out a few values. We know slope-intercept form is quite simply the easiest to work with when we're graphing. So let's go ahead and convert this to slope-intercept form. Let's go ahead and flip it so our y is on the left side. So 4y equals x plus 4. Let's go ahead and divide through all three terms by 4 so we can get y by itself. So we have y equals, we can separate x out of the numerator, and that'll give us 1/4 x plus 4 over 4 is just 1. All right, so this is our slope-intercept form for this equation, so we're actually not going to worry about this one anymore. Put a line through it so it doesn't confuse us. Here we just need to divide through by minus 1 so we can get a positive y out front. Those two negatives will cancel, which gives us y equals 3 over minus 1 is a minus 3x. 2 over a minus 1 is a minus 2. And so this is our system of linear equations, these two equations here. So we can call this line 1 and line 2, and we can go about business as usual. Again, we'll pick out some values for x, plug them in to find a few points for each line, and then we'll graph them. All right, so let's go ahead and do this. We'll go ahead and start with line 1, described by the equation y equals 1/4 x plus 1. All right, so let's pick out some values. Well, x equals 0 looks very good to me because that'll cancel out this fraction. So we have y equals 1/4 times 0 plus 1. That'll cancel, so we have y equals 1, which gives us our first point of 0, 1. All right, so that's our first point. Let's go ahead and pick out a few more values. Since we have a denominator here, why don't we just go ahead and pick out x equals 4, and that'll cancel the denominator and we'll stay away from fractions. So when x equals 4, y equals 1/4 times 4. Excuse me, times 4, that's not 9. We'll get this eventually. Plus 1, the 4's cancel, so we have 1 plus 1 is 2. That gives us our second point of 4, 2. And let's just go ahead and use minus 4 to get our third point. We always want to incorporate a negative and a positive when we're working with our x values. So we have y equals 1/4. Y equals 1/4 times a minus 4. Excuse me. Sorry about that. Plus 1 equals, these two terms cancel, so we have a minus 1. We're not canceling the minus, just the 4, so we have minus 1 plus 1 gets us 0. So we have minus 4 and 0 as our third point. So these are our 3 points for line 1. Let's go ahead and find 3 points for line 2. Line 2 is described by the equation y equals minus 3x minus 2. All right, so let's go ahead and pick out a few nice round values to make our calculations easier. So 0, when x is 0, y equals minus 3 times 0 minus 2. So that'll cancel, so we'll just have y equals minus 2, giving us our first point of 0 minus 2. It's just that x value and the y value. And we can go back to picking some very simple points of 1 and minus 1 for our other two x values. Y equals minus 3 times 1 minus 2. Minus 3 and 1 is minus 3. Minus 2 is a minus 5. So we get the point 1 and minus 5. And just for thoroughness, we'll use another negative number for our x value. So y equals minus 3. X equal minus 1, minus 2. These two terms, the negatives cancel, so we have 3 times 1 is 3, minus 2 is 1, and we get our third point, minus 1 and 1. All right, so far so good. We have 3 points for each respective line, so let's go ahead and plot them on our graph and see what this thing looks like. Here's our y-axis. Here's our x-axis. All right, we don't need to scale this too much. Our values are fairly small. All right, so our first line goes through the point 0, 1, which is right here. It goes to the point 4, 2. Let's go ahead and scale it a little bit more. It goes to the point 4, 2, which is right here. It goes to the point minus 4. Goes to the point minus 4 and 0. So minus 4 and 0 is right here. Let's go ahead and connect them as straight a line as possible and go through all 3 points. That was actually a little better. The domain and the range of both lines here are all real numbers. We can plug all real numbers into these, so they can continue infinitely in both directions. And this is the line described by the equation y equals 1/4 x plus 1. Now we'll go ahead and use the final sloped intercept form and forget about this first standard form. We didn't want to use it anyways. Okay, so let's go ahead and graph the second one. Our second line passes through the point 0, minus 2, 1 and minus 5, 1, 2, 3, 4, 5, and minus 1 and 1. Somewhere right about there, almost on the second line. So that's actually, we'll look at that in a second. Let's combine the, oh, there we go. All right, so that goes through all 3 points, continues infinitely in both directions. This is the line described by the equation y equals minus 3x minus 2. Okay, so we got our 2 lines here. We see how they relate to each other, and we see that they almost intersect at one lattice point, or a point where both x and y values are whole numbers, but not quite, because the exact solution for this system of equations is minus 12 over 13 and 10 over 13. So it's not quite at the point minus 1 and 1, but it's almost. It's very close. But again, that's not what we're looking for when we're graphing two linear equations or a system of equations. We're just wanting to know what the visual representation looks like. We want to get a good handle on actually how to graph them on the coordinate axes and labeling our lines as such. So we'll in the next few videos. Well, the next one we're actually looking at an application where we're solving a system of linear equations to solve a real-world situation, and then future videos we'll look at how to actually find these exact points for the intersection. We've seen them before. We'll be using intercepts and such, so we're just going to be using tools that we already know how to use, and we'll put it all together in some future videos. So I'll see you soon.